At the present time, when competition is becoming keener and costs are rising, much of British industry is handicapped by the legacy of the past, a legacy of cramped and unsuitable premises where methods, in some industries, have changed little since they first began. This galvanizing shop is a typical example where such conditions make work that contributes nothing to the main job of galvanizing and adds nothing to the value of the product. Hauling on rope hoists. Sawdusting by hand. Moving by hand and over unnecessary distances. Loading by hand. Pushing old-fashioned trucks over uneven floors. Stacking goods on the floor. These are methods that consume more time and effort than the actual work of galvanizing. In this factory, the management is well aware of the need for reorganization and is, at this moment, with the help of work study, planning for the future. The new plan aims not only at providing new equipment, but at introducing new methods that will reduce the distance the operators walk when dealing with one batch of products from 5.5 miles to less than half a mile. Clearly, in an old factory, work study can do much to help the management and the operators. Can it help to improve output in a new one? Here is a modern works, built only a few years ago, well designed and good to work in. Galvanizing is a process of coating steel with molten zinc to protect it from rust. In this modern plant, the articles to be galvanized are brought to the pickling tanks on pallets by forklift truck. Moved from tank to tank by electric hoist and monorail. Then, by creeper conveyor through a drying tunnel heated by waste heat from the zinc bath. Thence to the bath itself, which is also served by electric hoists and monorail. Special racks enable smaller articles to be dipped 50 or more at a time. Finally, the finished product goes on forklift trucks to the stores where vertical stacking saves valuable floor space. So by better layout, better handling methods and equipment, productivity has been increased. Can it be increased still further? The answer to this can only be obtained by a work-study investigation. In this firm, work study has been accepted by both management and men as a reliable means of improving output. The first step is to hold a meeting to explain the objects of the proposed study. There must be cooperation by both supervisor and operators. Galvanizing is essentially a team operation. The problem is to study the work of each member of the team without having to employ a number of trained and experienced work-study men. The same problem faces management in many other businesses. How to study, for instance, the work of sales assistants in a big department store, a team in a rolling mill, clerical operators in offices, or construction gangs in the building industry. One answer is the method called activity sampling that we see here being used to study the work of a team on a building site. The observer records at random intervals, to avoid coinciding with the work cycle, what each man is doing at the actual moment of observation. For instance, if the barrower is wheeling a load of concrete, he records transporting. If the loader is waiting, he records non-productive. If the spreader is working, he records spreading, and so on. The study must be carried on until the number of recordings is sufficient to ensure accuracy and to cover all normal variations in the conditions. Loading, non-productive, spreading, transporting, non-productive, non-productive. When the study is completed, the recorded activities are counted, and the totals show what percentage of time each member of the team spends on each activity. In the galvanizing works, this technique of activity sampling was employed to give a general but accurate picture of how the bath and bath team were actually used over a typical week. When some 3,000 recordings have been made, each person and piece of equipment, the work study observer compiles totals and calculates percentages for each. From these figures, a utilization chart is prepared. This shows immediately the proportion of time the bath is in use and how the team is working. What on the shop floor might look like a reasonable utilization of the bath and team now looks quite different. On an average, nearly half of everyone's time is found to be non-productive, as shown by the black columns on the chart. So activity sampling has shown what is actually happening in this galvanizing section, and, more important still, it has shown how much improvement remains to be made, and exactly where further and more detailed work study can profitably be applied to the team. This more detailed study concentrates on the galvanizing of one specific product, a 40-gallon cistern, and another work study technique known as memo motion, or time-lapse photography, is now used. The film camera automatically takes a shot of the galvanizing team every second and records all that is happening round the bath at that moment. The observer himself is free to take additional notes about the human factors involved in the operation, factors which the camera cannot record. There are 5 men in the team. The work cycle starts with a galvanizer. He, the team leader, is responsible for the whole process. His job starts when he tips a cistern into the bath. The feeder assistant moves the cisterns from the drying tunnel conveyor to the bath side. And also helps to skim back the ash from the top of the molten zinc. The third member of the team, the galvanizer's assistant, helps with the skimming process, which allows the cistern to be withdrawn from the bath through clear zinc. The galvanizer uses a rod to hold the cistern and lever it from the bath. The fourth member of the team, the crane man, starts work when he hooks the electric hoist onto the rod and raises the cistern slowly clear of the bath. A short delay then follows while the excess zinc drains off before the galvanizer signals the crane man to move the cistern to a position away from the bath where it is lowered to the floor. After the crane is unhooked, the galvanizer and crane man return to the bath, and the fifth and last member of the team begins work on the cistern by wire brushing and removing burrs. Second by second, the camera records the position and activity of each member of the team and whether the bath is being used. The operation of galvanizing 40-gallon cisterns was chosen for this investigation because it is one that necessarily involves a certain amount of manhandling. When the work cycle has been photographed many times, the pictures are examined one at a time. The advantage of the film camera is now apparent. For each second of the cycle time, every detail of the operation has been recorded for analysis and critical examination in the relatively quiet atmosphere of the office. For instance, here the galvanizer is moving to the fettler. The feeder assistant is delayed. The galvanizer's assistant is skimming. The crane man is moving. The fettler is delayed. The bath is idle. In this study, the work cycle has been filmed 50 times to ensure that all possible variations have been covered. The work study man, having analyzed each picture of every second of the operation, can run through them quickly to make sure that no important variation in the conditions has been overlooked. He then transfers the information given in these pictures to a multiple activity chart. This chart clearly shows the relationship between the work of the different operators and the extent to which each is being delayed, shown by the white areas on the chart. Look, for example, at the galvanizer's assistant. He seems to spend most of his time in delay. In fact, his only actual work is to help skim the bath. And from the technical point of view, too much skimming may do more harm than good, since more ash is formed and zinc wasted. The first thing the chart shows is that the team could be reduced to 4 men. But it also reveals that the cycle time of each operation is 1 minute 52 seconds, and that the determining factor is the work of the galvanizer. Can we relieve him of some of this work and so reduce the time of his work cycle? If we can, it will then be possible to reduce the times of the other members of the team. Let's take another look at what he does. He's a skilled man doing a skilled job. But when the cistern is being raised from the bath and is draining off, all he does is to hold the end of a rod, and he wastes time holding onto the rod while the cistern is brought to the fettler. If a hook attached to the hoist is used to lift the cistern, the galvanizer need no longer hold the rod. He is now freed to remove surplus zinc from the cistern. And as soon as draining is finished, he can get on with his own skilled and productive work of galvanizing. This simple improvement reduces the galvanizer's work cycle. But more important, it enables the work of the team to be rebalanced so as to reduce delay to each member. And the final result is to reduce the cycle time for each cistern by half, to 56 seconds. Or, in other words, to double productivity. But it is one thing to improve an operation on paper by the use of work-study techniques, and quite another to get the new method adopted in practice. The installation of any new method involves the complete cooperation of all those expected to use it. This includes the supervisor, who is responsible for ensuring that the new method is operating in practice. In this one simple galvanizing operation, it has been shown that the plant and labor utilization, or productivity, can be doubled. The galvanizer's assistant, now promoted to feeder assistant, is transferred to another bath, so that the company does not lose the services of an experienced man. This increase in productivity can be repeated many times, not only in this factory, but wherever teamwork is done. Remember this: 3 men each doing one job: loading, barrowing, and spreading. Well, after analyzing the observations, the work of the team was properly balanced. Now the spreader helps with the barrowing by wheeling the first barrow load of concrete from the mixer to the site. He then gets on with the job of spreading. The barrower, after loading his own barrow, positions the third barrow under the mixer before taking his load down to the spreader. The loader, after emptying the mixer into the third barrow, recharges the mixer before taking his load to the spreader. The barrower, meantime, returns to the mixer, where he is eventually joined by the others to help recharge the hopper. The result? An increase in the rate of output of cubic yards of concrete laid per man-hour of 60%, and a saving in costs of 40%, in spite of increased earnings by the men. Even in the most modern works, with the newest equipment and latest handling methods, work study can always find still further means of improvement. Can this new method be improved even more?